Hey, alright, let's give this a try. I'm going to work out a few of the problems here, and I'll try to stay out of the way as much as possible. We'll have the sets that were given in the notes: u equal 1 through 9, a equals 3, 5, and 8, and b equals 2, 3, 5, and 7. So the first two are easy. The union is just the collection of everything that's in both a and b. So 2, 3, 5, 7, and 8. Where the intersection is the stuff that's in both A and in B. So the union being everything that's in either or, the intersection being in everything that's in both and. So I see 3 and 5, right? There we go. This one's a little bit more interesting. It's a bar, also known as a complement or a superscript C. So that means that we want everything that's in A not in A and everything that's in B. So we have to think about U. U is 1 through 9. So everything that's not in A will include things like 1, 2, which happens to be in B also. Now 3 gets to be in here because it's in B, even though it's in A. 4 is not in A, so we keep that. 5 is in B. 6 is not in A. 7 is in B. 8 is in A, and it's not in B. But 9 is not in A. So look back over those. The only number that I did not include in the answer is 8. Every single one of those numbers is either not in A, that would be, for instance, 1, 2, 4, 6, 7, and 9, or it's in B, which includes the 2, 3, the 5, and the 7. Now let's try the intersection. This will be a good bit smaller. This has to be either, it has to be both, not in A and in B. So if we look at the smaller set, B, 2, 3, 5, 7, and collect only the things that are not in A, then we'll have 3 and 5 left out. All that we have is 2 and 7. It may be nice to have a picture of this one, especially since when we do the last problem here, B minus A is the elements of B subtract the elements of A. Again, we leave out 3 and 5, and we get 2 and 7. There's a reason for that. Those two are always the same. Let's look at the whole picture. So here's a picture of U. Has all the sets, all the numbers 1 through 9. So I'll show A and B as our example. The intersection we found was 3 and 5. A also includes the number 8. So this is the set A here. Put it right on top. And B also includes 2 and 7. That's B there. And then the rest of U is 1, 4, 6, and 9. Did I miss anything? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. So let's look at the complement of A bar. That's everything that's not in A. So I shade everything that's not in A. It includes some things that are in B, of course. Just all the area that's not in A. I shaded everything except the circle A. And now I'm interested in just the intersection of that with the circle B. And now I see that that gives me the numbers 2 and 7. Those are the two numbers which are both in B and not in A. But it's exactly what I get when I take all of B and subtract A. Those two are always equal. We can write for any two sets, S and T, that relationship holds.